so much for coming to the Earth Engine for REDD. We're very happy to have you, and we're very happy to have 4 wonderful speakers talking about how they and their organizations are using Google Earth Engine for REDD, reducing emissions from deforestation and degradation. And so first up, we're going to have Erik Lindquist, Forestry Officer from UN Food and Agriculture Organization. Then we're going to have Sylvia Wilson, Forest and Climate Scientist from USGS. Then we're going to have Derje Likisa-Biene, who is an MRV specialist from Oromia, a region in Ethiopia, and his REDD Coordination Unit. And then we're going to have Luke Sanford, an assistant professor at Yale School for the Environment. It's very exciting. These individuals are going to give different perspectives of how they have been working in REDD, from the science to application to MRV and more. So very excited to share these different perspectives, and then hopefully at the end we'll have time for questions and discussion. All right? First up is Erik Lindquist from UN FAO. Come on up.
Thanks, Karen. Hi everybody. Good afternoon. Welcome to the post-lunch session on the last day. This is the coveted time spot. Anyway, my name is Erik Lindquist. I'm a forestry officer with the United Nations Food and Agriculture Organization, and I'm going to talk about GEE for REDD, or something I just coined last night. And if you haven't coined it already, feel free to use it. REDD-E. REDD-E. Has that been used? It has? Okay, so I'm not going to talk necessarily about how we use, not a lot about how we use GEEs, the specifics for monitoring REDD. This has been talked about a lot this week. But what I really want to focus on are the metrics we're starting to try and collect that enables us to judge the impact of not only our tools, but Google Earth Engine and all that stuff, to start being able to communicate not only to people everywhere, but specifically my bosses and other bosses and things like that, just how important and critical these platforms and tools and things are for our work. So this is one metric that everybody is probably familiar with, the carbon dioxide concentration in the atmosphere. And what I would really like to be able to show you today in terms of a metric, we had our FAO graphics team hard at work on this. What I really like to be able to show you is this as a metric. But I can't. So we have to choose some other ones for the time being. But I would still like to keep this in mind, for as Erik Dinnerstein said today, what do you want from 10 years from now? Wouldn't it be fun if we had a better line than that, but a similar shape? Right, I just talked about that. What am I going to do? So this is, I'm just going to start out really basic, trying to quickly explain what REDD is, reducing emissions from deforestation and forest degradation. And this is basically, in a nutshell, what we're trying to do. Trying to take the area of deforestation and forest degradation, multiply it by an emission factor, or how much carbon biomass is in that area, to produce an emissions estimate, an estimate of emissions. And that's all we're trying to do. It's a very simple equation, nearly impossible to get right. And this, again, the graphics department was working overtime. This is REDD in a nutshell. We have a reference emission level that, as business as usual, the amount of emissions an entity has been producing in the past. We have what they call REDD plus actions. Those are actions that people are taking, management actions, legislative actions, to reduce the emission from the business as usual scenario. And then we have, hopefully, the reported emissions decreasing over time. And that's, again, sort of REDD in a nutshell. So these are the countries in the world that have submitted a reference level, it's called, to the UNFCCC, the United Nations Framework Convention on Climate Change. It covers 33% of the global forest area and 75% of the global deforestation. I realize I'm kind of standing right in the middle of the slide, sorry. But anyway, and you guys, seriously, this is sort of a back of the envelope calculation, so this has not been checked. So some of this might not be quite right, but this is right. These are the countries that of those countries that have reported a reference emission level to the UNFCCC, these are the countries using Landsat to generate those data, and these are the countries using Sentinel products to generate those data. Some are using both, obviously, but yeah, some are just using one, or some are using one or the other. And this is the resulting REDD Plus results being reported to the UNFCCC. So you can see that some are not reporting results, so some are 0. There's one that's negative. That means the emissions are actually increasing over time from the reference level. And then there are other countries that are reporting various levels of emission reductions. Brazil, of course, is in a league by itself, like 9 billion tons of CO2 reported, like emission reduction reported. But all the other countries are there as well, and then some are preparing to produce this information, REDD Plus results. But still, all these countries are using that satellite information to generate these results in some way. These are the REDD Plus countries that we think are using Google Earth Engine in one way, shape, or form, whether it's just using the GEE code editor or whether it's using tools and platforms built on top of GEE. This is the one I'm maybe not sure about, because the reporting, they should report the methods they used to generate the information, but some of them don't do that, and it's really sort of sketchy. But from my personal knowledge of the results generation process, this is what I get. And that is the equivalent of 1.6 billion tons of carbon dioxide emissions reduced or from a business as usual scenario. So we're trying to say that, and this is between 2006 and 2020. So what we're trying to say is that, you could attach the importance of a platform or whatnot, data source platform, to this number and get at the importance or a measurable metric of how important something like Google Earth Engine is to this effort. Is that a big number? I don't know. I mean, you look at the numbers are massive in scope, and this is kind of a drop in the bucket relative to how much is being emitted, but still, there it is. And of course, then GE gets used for a lot of other things, right? So trees are not all created equal, so we're using Earth Engine to get at that third dimension of things, so the volume of stuff, not just area, but remember area times volume. And so we're also using Earth Engine and Earth Engine tools to get at that. This is another way of judging impact, I guess. It's not as quantifiable as maybe billion tons of carbon dioxide, but it's capacity. And it's capacity to generate statistics and reports to other groups. So this is the increase in capacity to use remote sensing imagery, and it comes from this paper, so I highly recommend checking that out. But it's the increased capacity over the last 10 years or whatever to 15 years to make use of the data. And I would say quite comfortably that is in large part due to the availability of the imagery and the availability of Earth Engine. So we build openforest.org, which are tools to help countries generate this information, access these data, and produce these statistics. So it's all free and open source. You can, more than 90% of those countries are using openforest.org in some way to generate that information, and anybody can access and use those data. We have over 100,000 users of OpenForest, and these are sort of metrics of specific to OpenForest. Oh, that means I'm done. This is specific to OpenForest now, other metrics by which we can judge success or failure or where we need to improve over time. And those are some numbers about metrics, and hopefully in 10 years' time, I can show you the corresponding decrease in carbon dioxide emissions at Mauna Loa Observatory. So with that, I thank you very much for your attention.
So Next up, we have Sylvia Wilson, who is from the US Geological Society and Silvacarbon. Come on up.
Which one?
Either one, and here's your clicker.
Okay.
And then
Hello.
it's also here, and any speaker notes are there.
Okay. Hello, good afternoon, everybody. I'm Sylvia Wilson from the US Geological Survey. and yeah, it's USGS, and I have been working. I'm very glad that my presentation is after Erik. Before the year, because I won't be talking about REDD specifically, but I won't be going into country specifics either. So I'm just gonna explain a little bit how our capacity building programs at USGS works to assist countries generating data for reporting to REDD+. So I work for USGS, and we have two capacity building programs there. One is Silvacarbon, and the other one is a program from the Committee of Earth Observation Satellites, CEOS. Both of these programs aim to help countries to use remote sensing data and ground-based data to build national forest monitoring systems for reporting to REDD. So the difference between the CEOS and the Silvacarbon program and what we do is that the CEOS is focusing in global data sets, looking at global data sets that many developers, universities generate of land cover and also biomass are used in countries or can be validated and calibrated with country-based data. So the countries can use it to report to the UNFCCC. Sadly, now, most countries don't use global data sets that are just available because they have different definitions, different classifications. They're pretty much done with defaults, so countries don't use them. So the role of CEOs is to, or our role as a capacity building program is to bring the countries together with these developers and calibrate these global maps, so the next iteration of the maps is better, and then countries can be using those products. And with Silvacarbon, we're working exclusively with each of the countries, looking at what are their needs in terms of capacity. So it's a little bit more focused. Excuse me. For both of them, we're using Google Earth Engine. For both of them, our course since 2016 is to work in collaboration with Google Earth Engine, because otherwise we clearly can do this. I mean, to be able to generate data as a jurisdictional level REDD is very difficult if we don't do it with cloud computing. And we rely on platforms like CPAL, so we work very close with Erik, Collect Air Online, and the Global Forest Watch, who are running within Google Earth Engine. Okay, so our process is very simple. All the capacity building programs that we have are driven by the countries. So we don't come out with an agenda to the countries and say, this is what you have to do. They tell us what their needs are. So first we go to a country and we do kind of like a scoping trip with different agencies and different partners. We do it with FAO, with Google, with others, and they tell us, we need this. Then we evaluate it, get some feedback, and then we include tools into the national forest monitoring systems that provide training. And the ultimate goal is that the countries can replicate these processes without us, right? That we're getting removed out of the equation there. That hasn't happened yet. Since 2011, we're still working with countries, but that's the ultimate goal. And here are our 30 countries. So we work in 4 regions, and we started in 2011 with Latin America. We have more countries in there. Then Southeast Asia in 2013, Central Africa in 2015, and 2020 we moved into the Pacific Islands. And from the 30 countries, 26 are in the Lima Hub with their forest reference level submissions. From those countries, from the 26 on the reference level submissions, the 26 mention Google Earth Engine. And I agree with Erik that when you go into the submissions, it's not very clear. Some of the countries don't put all their methodologies in there, but the 26 Silvacarbon countries have done this, so we know for sure that Google Earth Engine is used for either accessing data, for facilitating the use of other tools such as CPAL and Collect Air Online, for accessing high-resolution data for validation processes, for accessing the entire archive of Landsat and Sentinel for sample assessment and other things. So we have a compilation of how do they use Google Earth Engine. Definitely some of them use it for one piece and then take everything out of there and put it in ERDAS, but there is pieces where Google Earth Engine is key for this reporting, for the generation of the data for reporting. Okay, so we've been working since 2011, so we hope that we have some success because they haven't shut them down yet, and so we keep going. So it's very difficult to quantify how many carbon emissions our program helped reduce because that's actually the work of the countries, but we have different metrics, right? And they're very diffuse. We can't really put a finger on it. We can say how many the number of women we train, the number of men we train, hours of training per year, those things. But those things are not really reflect the success of the program, of the capacity building program. So we do have assist countries in their submission of the forest reference levels. We have generated capacity in countries. We know for sure that when we started in 2011 training people, those people, some of them are still there because of our programs we're working with them. And we develop partnerships. And that's a very important key thing because REDD is big in terms of donors. So you have a country that have Norway, FAO, Silvacarbon, many talking to the same person is really overwhelming. So we develop partnerships and we usually work very close with FAO. So we don't have Erik and I talking to the same person at the same time for the same thing in a country. So they just talk to me, not to Erik. No, just kidding, Erik. But I mean, that's the point. It's like to avoid duplication of efforts and to come together on these partnerships. So I have two examples of success stories here. One is Paraguay, and the other one is Guatemala that I showed yesterday. For the Paraguay, they haven't yet got all the way to the calculation of carbon emissions, but they're talking about the deforestation area, right? So it's the forest cover and how it has been reduced or not. They have a report since 2005 to 2020, and the next report is from 2020 to 2022. It's in Spanish, but if you see the second column, it says GEE. So what they're actually saying is that the generation of mosaics were done in Google Earth Engine. And they actually have a change of methodology where they include Google Earth Engine since 2017, I think. And so they improved their methodology. And there is some results. So Paraguay is 44% of forests, and mostly native forests, but also they have plantations and palm. And so there is two regions, the west region and the east region, where most of the deforestation happen in Paraguay. 83% of forest cover in the west region and 17% in the east region. So between 2020 and 2022, 88% of the forest loss, the native forest loss, happened in the west region, but it happened inside management plans. So that was kind of key because they were planning for this land use change. So the trend in conclusion is that they were able since 2005 and 2022 to decrease deforestation at a national level. And I explained this yesterday for Guatemala. They have two submissions of forest reference levels, one 2006, one 2016 to 2016, and the other one from the 17 to 2021. They show that the total deforestation decreased over there by about 2 million tons of hectares per year, but they did show that the total degradation increased, and that's because they were using platforms as Google Earth Engine, and they were accessing high-resolution data, so they were able to detect small areas of change, and then the increase of carbon stocks decreased. So they were actually that was a minus on their total balance. But still, Guatemala improving methodologies using cloud computer have a balance of 2 million tons of CO2 per year. Okay, so very fast. So for now on, we have 5 areas for capacity building. One of them that I want to talk right now is about mangroves mapping and monitoring. And why? Because mangroves hasn't been really considered in forests in these submissions for a long time. But if you consider mangrove forests, mangroves is reporting as REDD+. But if countries consider mangroves wetlands in their greenhouse gas inventory, then they're considered blue carbon. So right now we're working with countries that including mangroves as forests to be able to monitor the carbon from the mangroves, which is more difficult than the forest because most of the carbon is below ground. So we're using remote sensing and we're working with different institutions that have GUIs, scripts, and other tools built into Google Earth Engine already. And we are also doing field surveys. We're going to countries and measuring below and above carbon biomass, and we're doing the integration to calculate the final carbon emissions. So here are some of the tools and the applications that happen for mangroves in Google Earth Engine. These are done by NASA Goddard and by UCLA. And and so we have since 2022 started working with the countries, having regional workshops to be able to collect this data and then integrate it with remote sensing data and come back with some carbon emissions at the jurisdictional level. So we have one in Fiji in 2022, one in Thailand in 2023 in February, and then one a couple of weeks ago in Guatemala. And that's all. Thank you.
All right, so we'll take questions at the end and keep moving. Next up, we have Derege Lekisa-Biene. He's going to talk about his REDD work. Derege.
Yes.
Thank you very much. So you can take this if you want to walk, or you can stay here. And if you have any notes, they'll be there.
Okay. Thank you. Welcome. I'm Derege, MRV specialist for Oromia REDD Coordination Unit. I'm going to present you first. I will focus on what we are doing, and then later on, I will focus on how we are integrating our activities into Earth Engine data. Where is Oromia? Oromia is in Ethiopia. It is located here, and the program is Oromia Forest Landscape Program. It is a pilot program for Ethiopia in order to reduce emission from deforestation and forest degradation. And the region is selected as a jurisdictional REDD+ program because of the huge resource in forests as well as the unsustainable management of land resources. So the government of Ethiopia is wanted to address those issues, piloting initiative for sustainable forest landscape program across Oromia region. And how can we get emission reduction result-based payment? What is our base? So the initiative for sustainable forest landscape have its own requirements, especially the 6 are the main requirements, and we have 2 phases for emission reduction result-based payment. The first phase, which is January 2022 to December 2024, and the second phase is 25 to 29. And the second phase includes forest land, remaining forest land, and the enteric fermentation, which is called AFOLU. And the first phase focuses on deforestation and afforestation activities. So when we get payment, the payment can be achieved if we are success, since it is result-based payment. So there is a baseline, and from the baseline, if we go as a business usual, we cannot really get emission reduction result-based payment. So because of the activities that we are doing, we are expecting emission reduction result-based payment, and the emission reduction is because of the activities we are doing and the activities we are implementing on the ground. And then in order to get this one, we are compiling different activities which are implemented by different initiatives, different sectors. So this is the engagement map of those initiatives who are doing on emission reduction activities. And this is a Raki matrix, which shows the institutions as well as their activities. Those activities are compiled, and we have in a database, and we will going to calculate the emission reduction based on the activities that is conducted by every initiatives. And these are some activities which we are implementing in the region. The first figure shows you different activities like afforestation, reforestation activities, forest management activities, as well as we are coordinating CBOs, community-based organizations, in order to develop forests as well as in order to protect forests. So because of they are working on that one, if we are successful, we can get result-based payment. And the last figure shows you the Green Legacy Initiative, which is a huge initiative on the forest development activities that the government of Ethiopia is enacting on. So within 5 years, there is 5.7 billion tree seedlings are produced and planted. And in order to get this one, we made an agreement with the Initiative for Sustainable Forest Landscape program, which is by World Bank. And there is ex-ante estimate. Based on the activity that we have, we estimated that 45 million tons of carbon dioxide can be reduced within 10 years. If we if you minimize the buffer, we can have 23.8 million tons of carbon dioxide across the region. From this, we agreed with the Initiative for Sustainable Forest Landscape Program, World Bank, for 4.87 million tons of carbon dioxide with $40 million. And in addition, we wanted to sell additional emission reduction with about $20 million. So what we are doing and how can we monitor? The first figure shows you the monitoring activities that we did during 2018. And the second one is the monitoring activities that we did during 2022 at zonal level. Since emission reduction result-based payment is paid at zonal level, we have to cascade at a large scale into a zonal level. So for this one, we collect 3,758 using collect airs, and as well as we used CEPAL, and Airs Engine has a very important role in order to collect this data. And look, this one is 92,820, which is huge data, which is collected by Collect Airs Online, integrated with Airs Engine data, Airs Engine app. So the way we collect is this one. This is a questionnaire developed and deployed on the Collect Airs Online. This is the Airs Engine data. It gives you an information whether the land is forest, cropland, whether the forest is deforested or degraded or something. So Collect Airs Online, CEPAL, and the Collect Airs Engine are our main source of platforms in order to analyze this one. These are the results that we get from the monitoring activities for the first 2080, where 772 million tons of carbon dioxide is emitted during our monitoring period. And also for the second at zonal level, we summed up, we have deforestation level about 34,000 per year, which is monitored, which is equivalent to about 12.7 million tons of carbon dioxide per year from the region. This is our baseline. This is already presented by Erik. Thank you. And another information that we have is this is Bale Ecoregion REDD Plus pilot program. This area is one of the 45 heritage sites which is recognized by UNESCO now. And we calculated and we get about 9.8 million euro for the community who are engaged into protect this activity. Currently, we also, from 2020 to 2021, we calculated 6,000 emission avoided deforestation from this area also. We are negotiating with the carbon buyers. Look, this is the way we are using, the way we integrate our analysis. This is Collect Earth Online. After we designed our survey on Collect Earth Online, we deployed it, and then we use this Collect Earth Online. This is a survey equation. You can download into the and integrate into Earth Pro, and or you can use Earth Engine app in order to analyze the data. So it enhances very well our analysis capacity. Another important case is we are going to analyze degradation activities in addition to deforestation, but we are not really get a good app and a good analysis technology and the methodologies for degradation analysis, but we have to submit it to the ISFL. So what we are doing is to detect canopy height as well as canopy cover, and then estimate the biomass of the region, across the region. So we have two things here, which is ground-based, which is National Forest Inventory, which is costly and time-taking. So in addition to that, we are doing a space-based analysis of deforestation as well as forest degradation. So we are detecting a canopy height, we are detecting canopy cover, and we are developing an algorithm in order to detect above ground biomass. And then later on, the data we will going to collect will help us in order to detect using land trender and the CDC on Earth Engine. This is the data we used. We used existing satellites imageries, and NICFI is very well imagery, high resolution, 5-meter resolution. Sentinel-2, Sentinel-1, VV and the VH polarizations are used. Sentinel-1 composite of all NDVI is used, aspect is used, slope is used. GLCM, gray level co-occurrence matrix, which is texture, is also used in order to detect this canopy height and the canopy cover using Earth Engine. These are the importance. We cannot really use more of the bands, so we have to be selective, and these are the selected bands in order to detect canopy height and the canopy cover. These are the canopy height that we detected. This is for Bale, and the validation, the training data showed the validation is good, but the internal validation showed us 0.67, which should be improved using a ground inventory data. And we used also 2,428 sample points, which is collected by Farm Africa, an initiative which are engaged in the protection of this area. So the accuracy is 0.89 using this one. This is the canopy cover, which is also similar. And we have 21 zones. We have 21 zones. We are really doing for each of zones this canopy cover, canopy height, and above ground biomass estimation, because of all zones are paid based on their performance, based on their baseline. So this is the highlight of the canopy cover and the canopy height across the zones in Oromia region. So what is Earth Engine for REDD? It provides integrated functionality for data and the analysis platforms. We can get so many data in this platform. We can integrate different data and we can use for analysis. It is very important for me. Sophisticated way of analysis: land use, land cover extent, change, tree structure, density, and the above ground biomass can be estimated easily from this platform. It is very hard to do these activities using another platforms for me. Mapping carbon potential and hotspot and linking with conservation activity. Which areas are needing conservation activities, which are deforestation hotspots, which are vegetation hotspots. Such activities can be made using the analysis made by using Earth Engine. So regularly monitoring and determine what forest management options are needed. Lastly, look, before 2 years, I was using ArcGIS manually. It takes me long time, about a year, in order to produce one activity data. Now it is simple, and we can integrate and we different data sets, and we can produce an activity data for REDD. Thank you very much.
Thank you, Thank you so much. Okay. Hope you guys are listening at your questions to be ready for Q&A, which is going to come right after our next speaker, Luke Sanford from Yale School of Environment. Come on up, Luke. Do you want this or this? Up to you.
All right, thanks a lot. And thanks everyone for being here after lunch today. So I'm going to talk about payments to reduce deforestation, but mostly in the context of carbon markets. So I want to give you a quick overview of what I'm talking about here and why it's important to put it in the context of markets. So carbon markets have a really important goal and one that works well in practice, which is to efficiently minimize carbon emissions. And the idea here is that the market is able to find the lowest cost mitigation or sequestration solution. So they work where if it's really costly for me to reduce my carbon emissions, I can find somebody for whom it's less costly and pay them to reduce their emissions. And as a result, payments flow to the people for whom it's optimal to reduce their emissions. And carbon markets are uncontroversially a net positive for the world. Okay, maybe not. So on the other hand, we have this quote from BCG, which says, in 2021, the voluntary carbon market grew at a record pace, reaching $2 billion, 4 times its value in 2020, and it's expected to reach between $10 billion and $40 billion by 2030. So what's going on here? Why do we have such different viewpoints on this issue? And I'm going to tell you it's all about baselines. And so I have a carbon project over here, and I've color-coded deforestation from the Hansen data set, where red is most recent deforestation, is yellow is least recent, or yellow, I guess, starts in 2000. And the baseline is what would have happened without the carbon project. And so the previous speakers in this session have focused a lot on the use of Google Earth Engine and remote sensing data to figure out what happened when there was a carbon project. And what I'm going to be telling you about today is how we can use that same source of data to try to estimate what would have happened outside of that project. So while it's really hard even to measure the changes in carbon stocks in the world we do observe, it's even harder to measure the changes in carbon stocks in an imaginary world that we don't directly observe. So a methodology is a way to imagine that imaginary world or how to create a baseline. And in general, for a carbon project, a developer will set a baseline, which is about how much carbon will be or would have been emitted or sequestered in the project. And additionality is the difference between the project scenario and the baseline or non-project scenario. So how much carbon did this project sequester? If you look at it, see if you can figure out how much it sequestered. There's clearly a little bit of deforestation in the project. Maybe there's a lot more outside of the project. But how much would have happened without the project? So it depends on what the baseline would have looked like. So I'll get rid of all the red and yellow here. We have the project. It depends on if the baseline looked like that, in which case there was no additional carbon sequestered or no avoided deforestation. Or maybe it would have looked like that. We have a patch of deforestation. Or maybe it would have looked like that, where we have a much larger area of deforestation. And which one of those we think is most likely will inform how many carbon credits we should assign to this carbon project. So the challenge here is the true baseline is unknowable. It's impossible to observe, because once you're under a carbon project, you can't know what would have happened without the carbon project. So our solution, it's actually not going to be applied to REDD. It's going to be applied to the California carbon market, some of the project offsets that go into that. And we're going to be using Google Earth Engine, some machine learning, some statistics in an estimation strategy called satellite double machine learning. So I'll give you a sense of what this looks like. And this is a project with Sungmin Kim. So we have a carbon project here. This one's near Savannah, Georgia. The green is a project area. We have a 2-kilometer leakage buffer around it and an 8-kilometer donor pool around that, which is going to help us figure out what would have happened in our carbon project. And using several years of satellite data, time series that we're going to featureize all the bands, we're going to build, and a bunch of other geospatial data, we're going to build an outcome model, which is what we think will happen on some point inside the carbon project or near it, based on years of remote sensing and geographic data. And we'll also build a propensity model, which is, does the point look like it's inside or outside of the project? So when we do this, we'll end up seeing what the expected biomass change was going to be for each location inside and outside the project. And also how much each point looked like it was going to be inside the project using only data prior to the start of the project. So this is like, how predictable is this project? And here's why we calculate these things. So we're going to use unexpected treatment status, or only the part of the project location that you can't predict prior to the start of the project, which looks like this, to estimate the unexpected outcomes of the project, which are the part of the biomass change that we were unable to predict using the imagery and characteristics from before the project. And the reason here is that any part of the treatment status that you can predict is not useful for telling us about what the outcome is. So a place that you can guarantee is going to be inside of a project area is different enough that we shouldn't be comparing it to places outside. So it doesn't give us information about the counterfactual scenario. And similarly, any part of the biomass change that we can predict prior to the start of the project can't be because of the project. And so we're trying to pull out all the pieces that's not helpful for this estimation strategy and use those to define a useful counterfactual. So we do this for all the carbon projects that go into the California Air Resources Board carbon market. And with those, we can estimate both how much carbon is sequestered or not by each project, and then estimate the overall carbon from that's being entered into the California carbon market. And what we find is that there's about 20 to 25% additionality from improved forest management projects, which generate offsets in the market. But for avoided conversion projects, we actually find no additionality. And we also find this interesting result, which is that landowner type matters, that tribal projects generate the highest quality offsets of any of the types. And we're doing lots of additional work in using remote sensing to improve project-based offsets. So this is one of many projects in this area. In the next session, actually, Megan Ayers, who I work with, is going to tell you about leakage, leakage detection empirically. So, okay, still have a few minutes left. Let's talk about jurisdictional REDD now. So we're going to switch gears and go from project to jurisdictions. Fortunately, we've had earlier speakers tell you a little bit more about what jurisdictional REDD is, so I can mostly skip this. But the difference between project level REDD and jurisdictional REDD, there are many of them, but the main difference is that a whole jurisdiction has to sign up as opposed to a single project, and we set the baseline at the jurisdiction level. So there are a number of advantages that people point out to jurisdictional REDD, including reduced risk of inflated baselines, reduced leakage, which I think is by far the best argument, scale, and changes to policy and regulation. And so this is Guyana. They issued some credits under the Art Trees protocol in late 2022. So we heard about this earlier, but this is how baselines are calculated for jurisdictional REDD projects that generate carbon credits. So we have a reference period, which here I've put in red. We have a performance period, which is in blue. And the credits that are assigned are the difference between what happened in the baseline period and the performance period. And so this goes through, you multiply it by the amount of carbon on the landscape to get credits. So what this project does is it says a baseline is supposed to be what a jurisdiction would have done absent jurisdictional REDD. And it turns out that we have a lot of data on this thanks to Google Earth Engine. So we can find all the jurisdictions in the world that would have been eligible for jurisdictional REDD. And we can look at what their behavior was or how much deforestation they had prior to the existence of jurisdictional REDD. And so we can compare what jurisdictional REDD assigns as their baseline to what their true baseline was, or what their end line would have been. And then we can calculate baselines for every eligible jurisdiction year, depends on the protocol. But if you are wide open to jurisdictions, we have about 1 million. And we can see how well the protocol baselines correspond to actual emissions. Okay, so this is how this works. We'll calculate the baseline end line for Mato Grosso for each year. So this is these are years in which there were not jurisdictional REDD carbon credits. So here we have a baseline that's higher than end line. So if Mato Grosso had signed up for jREDD in 2005, they could have gotten paid to do the behavior that they did. But if they had signed up for it in 2008 or in 2010, they wouldn't have gotten paid much. If they had signed up for it in 2014, they wouldn't have made any money. And in 2018, they wouldn't have made any money. And so we hope, on average, that the baselines are predicting the end lines here. And so we want to find out how much would we have awarded credits for behavior which was not a result of jurisdictional REDD. So I think in general, it's good to pay jurisdictions to reduce their deforestation. But if those generate credits which allow additional emissions, we have to be really careful about how we calculate baselines. Okay, so can we predict when it might happen that jurisdictions could strategically sign up for jurisdictional REDD and get paid to continue the behavior they already had? So we'll show you 2 tests here. One is, do increasing or decreasing deforestation rates persist? So if your deforestation rate is going down in the baseline, does that predict a lower deforestation rate in the end line? In which case, it's just that your behavior has already put you on a positive trend, and you can continue that. And secondly, if you have low deforestation in the last year of your baseline period, does that also predict a lower end line? And so we're just going to be looking at years prior to the start of jurisdictional REDD so that we don't have behavior mixed in here that's due to jurisdictional REDD. And so I won't show you aggregated results here, but the good news, well, first the bad news, which is that slopes and that last year difference are both predictive of performance period emissions, which means that in theory, it's possible for jurisdictions to game the system by signing up strategically for jurisdictional REDD. The good news is that there's no evidence of adverse selection in jurisdictions which have registered for any of the jurisdictional REDD programs. So we don't find that jurisdictions are signing up because they were going to be able to get carbon credits for not changing their behavior. And if you know anything about how jurisdictional politics work, or if you study political science like me, this is likely not a surprising conclusion. We have a number of other projects about jurisdictional REDD offsets, including how well HFLD methodologies work and the policy changes that are induced by jurisdictional REDD programs, and when and where we might expect to see certain policy changes. Thanks.
Okay, so can all the speakers come on up and we'll take questions and discussion. And I know a lot of times these end up being questions from the audience and answers from the speakers, but please feel free also to share, or if somebody has a question of the group as well, then let's get the discussion going.
Do I get a few minutes to rebut Sylvia's assertion that you should not talk to me? You should talk to her?
All right, any questions? Oh, yeah, I can be a runner. Hold on one second. I'm just trying to...
Yeah, thank you. First off, I think the 4 presenters gave really excellent presentations. I have a specific question for Sylvia. Given that you had the really great talk yesterday and followed up by the one today, do you have could you sum up maybe a few key points that you've taken from like the 10 years of capacity building activities that Silvacarbon has done, like maybe some of the things that you found that like really work well? And I guess it kind of goes, I guess, beyond just the use of Earth Engine. Thank you.
Okay, yeah, that is a difficult question. I think when we started in 2011, we thought that we have this idea of that we will be graduating countries, and this didn't happen. We just increased from like 10 to 30 over the years. And I think it's because in the business of remote sensing, things have changed so much. So 2011, we were working with hard drives of Landsat data in countries. And now there is so much data that they don't have the capacity to absorb it, right? To storage it and process it. So I guess one of the things that is good, but it's also a struggle, is the amount of remote sensing, the space data that is out there, and the fast changes, right? Because the countries decide on a methodology, but then 2 years after, something improved, something happened, there is something new, and they have to revise their methodology, and that can be a completely change of the first reference level, so it can be an improvement. So those things are really challenging. Yeah, that's kind of the takeaway I have. And maybe Erik, you can say something about that too, because. Sure. Yeah.
Sorry, I have a broad question for you, Luke. It's beyond your presentation, and I think I didn't quite follow. So my question is, what happened in a place that it's well preserved? There are no trends. So how is your system working? Sorry.
Yeah, it's a great question, and it's a really challenging scenario for estimating carbon credits. It's one in which trying to base your prediction on the future on only information from the past won't be successful, because there are lots of places where there's been no deforestation, but there is a risk of deforestation going forward. And if we use the past, we'll assign that place a risk of no deforestation. And so, more broadly, the solution that the first project would suggest, and I think is important, is to use information not just from the past of that location, but also of very similar places during the crediting period, to figure out, are places which have a similar risk of deforestation losing their forest, and how much? And based on that, we can assign, we can guess better how much deforestation or how much carbon emissions would have occurred. Similarly, the HFLD, or high forest low deforestation methodologies, have a way to take this on, which is more sort of deterministic. They assign a risk of deforestation based on a couple of factors that go into an equation, and they'll give credits to places which have a low history of deforestation to try to prevent deforestation in the future, because we know that many of those places are at risk.
Many questions. We can catch up later, because what's the spatial limit to that, to say that where's the risk?
Yeah, let's catch up after.
All right, thank you. I had a question for Luke about, so you showed countries that used historical average rather than the baseline slope. And I was just curious, I should know the answer to this probably, but do you know of many examples of countries where in their FREL they've used that slope? I know I worked with the Solomon Islands and they do that, but I don't see it very often elsewhere. And probably have a better, you can determine whether they deserve payments much better with the slope.
Yeah, so for that project, I'm really focused on the methodology which assign carbon credits. And so mostly focused on art trees and Vera JNR. And both of those use the historical average rather than the slope to assign the baseline or the historical emissions level. One thing that we're hoping to get out of this project is to get data-driven predictions of what the deforestation rate would have been for all those past years. And the challenge is then, like, how specific do you want to make it? Do you want to make it specific to forest type? Do you want to include things like distance to road, which we know is a big driver of deforestation? And so the more specific you make the model, the less interpretable it is for people who want to use that model to try to generate carbon credits. And so we're trying to navigate that space.
Yeah, some
I have a question for Derege. You had listed in there a forecast of megatons carbon equivalent between now and 2028, I believe, 2020 to 2028. I'm just curious how Oromia uses that in their planning of activities and programs on the ground, that forecast.
Thank you. We collected an information from the existing documents, and we also have initiatives document what they are doing on the ground, where they are doing, and on what area they are developing forests, and also on which area they are engaging in livestock activities in order to minimize degradation activities. Based on that one, we estimated using existing data. That is an ex ante, not exact.
And do you track every year how it's going?
Yes, we started to track every year now based on this Earth engine data. Before we don't have this chance. Now we look the data I showed you. You can track it next year or next month or 3 months later or quarterly. You can do that one. But since we have an algorithm, once the satellite images are active, you can monitor that one everywhere. Yeah.
Thank you. I think we have maybe time. They want me to wrap up because, but I know we have 3 minutes left, so we should wrap up right after Emil's question. Does that sound good? Thank you.
Thank you for your indulgence, Karen. I guess a final question for Erik. Just some of the stuff that we've talked about in the coffee breaks and stuff. How countries have used CEPL and how CEPL, I guess, pulls in different things. Could you maybe tell us about, I guess, kind of the evolution of the different kind of techniques that you see countries using more now than they did a few years ago? Also on this, thank you.
It follows up directly with what Sylvia was talking about. I mean, everything's changing. We all know, like, everything's changing so quickly, and now all of a sudden, the problem was data. We don't have data. We need more data, and now we have a ton of data, which is a great problem to have. And so, really, the challenge now is making sure that the data can be used efficiently, correctly, and quickly to get at an answer. So, any tools that help do that, especially in the context for REDD, or countries or technicians trying to figure out these problems with high precision. Anything that can help do that is a benefit, and that's where we've kind of put our emphasis is like, okay, so you don't necessarily need to be a coder. You can if you want to, but anything that makes the pipeline of data easier to wrangle quickly is a good thing, and so that's what we try to do, and that's what we try to promote with Sylvia and GFY and all the other institutions.